And I'm not going to spend too much time introducing Burçin Professor Gerber to you. Just quickly, bachelor degree at the University of Istanbul, master's, bachelor in architecture, master's of civil engineering at Berkeley, doctor of design from Harvard. Not bad. Even more than that, she's done things that other civil engineers have not done. For example, in 2012, you might know that there's a very, very well, and I suggest it to all people here, it's a magazine called the MIT Technological Review. It's very good on technology, explaining difficult concepts in simple ways. And every year they identify 35 people under 35 that are driving technology. These are typically given to computer scientists, to doctors, to biologists. About a bit more than 10 years ago, Burçin won it. The only person ever in civil engineering to have won this from the MIT Technological Review. Just to give another few awards that she gave, she's received a number of awards. Nominated, one of the youngest nominated to the National Academy of Construction, and just recently the ASC Computing and Civil Engineering Award, that one typically gives to people my age before they retire, as they retire, but you're quite several decades before that. So please, we're very much looking forward to what you have to say, Burçin.
Thank you, Jan. Thank you so much. Thank you. Good morning. The President, Professor Nemetek, Eve, the Dean. It was very inspiring to hear from all of you, and I hope I can live up to the expectations today, this morning. It's great to see some old friends in the audience, as well as meet with some of the new friends. Ian, thank you so much for inviting me to give this talk. Ian read my bio, but one thing that I cherish so much in my experience is between my doctorate after graduating from Harvard and joining the academia. I worked for 3 years in the construction industry. And I do cherish those 3 years, and I do feel like those 3 years contributed a lot to my thinking as a researcher. So, as Ian mentioned, I'm a professor in the Civil and Environmental Engineering Department of University of Southern California. And my research is non-traditional civil engineering, and I'll try to explain that to you today. And I'll try to challenge you a little bit about how you think about buildings. Well, today we are faced with numerous global challenges. There is not a single day that you go by in your newsfeed that you don't hear about some flood or a wildfire. And we do experience these extreme weather events to rapid urbanization, to resource scarcity. So while we are partially responsible for these pressing issues, we also hold the key to have the solution for them. With the unprecedented amounts of data and advanced intelligent computing in our disposal, AI offers remarkable potential to address these problems. Today, my talk is going to be a little different. I'll bring you into our everyday spaces. So, consider your typical day. Maybe just take to yesterday. Where did you spend your time? Was it in your home? Was it in your office? Maybe in a classroom? So reflect on the duration and nature of your time in these built environments. What did you expect from them? Did they meet your needs and adapt to your preferences? Or did they remain static and unresponsive to your needs? So, as we enter the new era of AI, we have the opportunity to redefine our built environments, in my opinion. making them more intelligent, more personalizable, sustainable, and centered around human needs. So my group at USC focuses on responsive and adaptive built environments. We imagine a world in which AI learns from and adapts to user behavior, predicting and responding to our needs in real time. So we call this human building interaction. It's a new field, and it is going to transform through AI the way we design, build, and operate and interact with our built environments by providing advanced tools for data analysis and predictive modeling, cognitive behavioral simulations, and these capabilities will empower us to make informed decisions and real-time control of our built environments in ways we prioritize individual needs, such as human performance and well-being, while achieving broader societal goals, such as inclusion, sustainability, and privacy preservation. To realize these objectives, it's crucial to build trust in AI, of course, and that was mentioned, trustworthy AI, and explore effective human-AI collaboration. So, how can AI be truly human-centered? I'd like to share some examples from my lab, and I'll start with highlighting the AI's role in optimizing building design and operation for occupant comfort and energy efficiency. So how often have you found yourself too cold or too hot in a built environment? So this is a line of research in my lab, and it's been going on for a long time, that tries to fuse subjective human data and objective building data to mathematically model human comfort and also integrate those models into buildings' operation systems. So think about, what if the building could anticipate when you become uncomfortable, when you might become uncomfortable, and proactively adjust the temperature before you even notice the change? So the graphs on the right side actually show some of our work where we're predicting those uncomfortable points and make adjustments in the built environment. What if we could design environments where not only building systems, but also the building elements adapt themselves to your preferences? This is a work between architecture, computer science, psychology, and my group. And here you see architecture responding to your needs. So this kinetic facade system adjusts in real time based on user preferences with energy efficiency as another objective in mind. However, it's not always fully adapted to user preferences. So in some cases, we have to compromise. So in this research, we developed a system that asked users who preferred more energy-intensive conditions if they would be willing to make small adjustments while informing them the potential energy savings. So we were able to actually make 70% of the occupants comfortable, while simultaneously reducing overall energy consumption of a real campus building by 30%. So taking the conversation to your furniture. So this is a collaboration between our group and a global engineering firm, Arup. So what if your furniture knew your preferences? What if your furniture knew who you are and what your needs are? Most often, centralized systems in a building are not able to meet all of our needs because of the system design. So we developed this intelligent desk equipped with multiple sensors, as you can see in the pictures, to learn, to model, to learn, and to monitor users' thermal, visual, and postural comfort. So the desk adapts to its users through personal heaters or fans, task lighting, or ambient lighting. And it evaluates individual scenarios and learns the most effective ways to negotiate environmental adjustments, fostering comfort and also healthier work habits. As I mentioned, comfort cannot be the only goal. In fact, fluctuating temperatures can benefit our health by lowering rates of diabetes, hypoglycemia, and obesity. In Europe, you do it so much better, in my opinion, than we do in the US, where we have very tightly controlled buildings. So in this research, we developed an intelligent box, let's say, that your preferences are met. But also we understand that automation preferences might change. I'm sure as I'm talking, you're thinking, I'm not sure about this kind of technology and if I want it. So we did try different levels of automation of these intelligent agents, from fully automated to manual. And there is a matching that is required in terms of level of automation, as well as the persons persons using it. But there are many cases where your building needs to communicate with you. So what if we could give a personality to your buildings? What if your buildings could communicate with you, where they are embedded with relational elements? So this is another research project where we have personified buildings as either building facility managers or the building itself, through text, communicating with you through text, through videos, or these intelligent agents. We found that the female agent personifying a building manager received the most compliance. But I'd like to show...
Hi, how are you?
This one.
I'm Ellie, representing your building. What's your name? I'm glad to see you here. If I open the blinds for you to have natural light, would you please dim or turn off the artificial lights?
So that agent that with relational features, have some social conversation, received the most compliance. So we are now looking into how to integrate these agents into the buildings, but there's so many interesting questions that AI can answer. What is the best time to approach a user? How frequently these agents should approach a user? What is the best timing of it? So let's now focus on how AI could be used for health and well-being within buildings. As you might know, buildings have significant impact on health, influencing both your physical and mental states. So there are two contrasting columns there, and I'm sure those two sets of images trigger different kinds of feelings. And I'm sure you've been to similar environments. So poor environmental quality causes symptoms like headaches, fatigue, respiratory issues. These issues actually create absenteeism, people not being at work, or presenteeism, even worse, being at work but not doing the work. And we have learned a lot from the pandemic. And we are now thinking about human building interaction strategies in response to diseases like COVID, including voice-activated elevators, touchless doors, water fountains, hands-free light switches, and such. But what if your building could tell when you're about to get a headache? And if you don't change lighting levels, or it's time to change lighting levels, or it's time to take a break because your stress levels are going up. So take sedentary behavior in offices as an example. Increased sitting is linked to higher cardiovascular diseases, diabetes, and other chronic conditions. But also, prolonged standing leads into issues like lower back pain and such, and discomfort. So in this research, we developed 3D posture algorithms that detect and alert you when your posture is unhealthy. We use several machine learning and computer vision techniques using open pose for body joint detection, as well as weekly semi-supervised human body part parsing for body part segmentation. We also use AI to automatically do the posture assessment, which occupational scientists usually do, and warn you if your posture is not healthy for a while. Well, during the first few months of pandemic, we realized, we conducted one of the first national surveys in the United States, trying to understand how office workers adapt their home environments. One thing that stood out was stress. Of course, there were pandemic-related stress, but we have also realized that indoor environmental quality factors affected people's stress levels. When we reviewed the literature, there's quite a bit of work in terms of use of AI in stress detection. Computer science colleagues have published quite a bit in this area. But they always treat stress as distress, which is the negative stress that you don't want. However, stress is not always negative. There's a phenomenon called eustress, which improves your performance, improves your personal growth and satisfaction. So our goal should be decreasing distress and improving eustress. So we have done one of the first studies using AI, differentiating eustress from distress. We have used physiological data as well as behavioral data, and we conducted a lab experiment with 48 individuals. Additionally, as I mentioned, we use computer vision algorithms to analyze facial expressions to detect signs of stress. So by integrating these data points, we provided real-time insights into individuals' stress levels, offering opportunities for timely intervention and stress management. I'll show only one graph, or maybe two, in this presentation. What we found is very interesting, and that goes back to the personalization of the environments. Gender played a huge role. Females perceive the tasks as more eustressing tasks, versus males perceive them as more distressing. So as you can see, some of the contributors to this for distress was skin temperature and electrodermal activity, versus for eustress, it is electrodermal activity and gender. More importantly, and you might think where I'm going with this, we looked at stress and productivity, which follows Yerkes-Dawson's law. So when you are bored, which means there's no eustress or distress, you are not interested in the task. When eustress increases, you're increasing attention and interest. Optimal performance is at the top of the chart. As distress takes over, you have impaired performance. So again, how can we create built environments that improve your performance through increased eustress? Most of the work that I have shown is in a lab experiment. So what we're doing right now is we're collecting data from 30 individuals over 6 months and looking at their environmental quality data, either at home or in their offices, as well as their physiological data, to be able to understand how built environments map into stress and productivity. So there's so many research questions here in terms of multi-domain IEQ effects to longitudinal comfort modeling, and recently we have included neurodivergent individuals so that we don't only design and operate buildings for neurotypical individuals, but we account for differences in individuals. So AI can not only transform how we interact with the indoor environments, but also enhance building safety through advanced threat detection, crisis management, evacuation routing, and recovery. So I'll give you a couple examples. We do use in emergency management type of research quite a bit of virtual reality, because this is one way to have ecological validity in emergencies. So in this work, we looked at how behavior influenced by building's design, type of building, and individuals' past experiences, people around them, and those they are responsible for. This is a real fire incident in a metro station in Beijing, and we collected data in London, in Los Angeles, as well as in Beijing. There are many cultural differences in terms of evacuation and how people use buildings. And specifically here, we looked at architectural visibility and crowd following behavior. We have also simulated active shooter incidents and created 2 versions of schools and offices, one the standard version, one with countermeasures recommended by the authorities. We try to understand how building attributes prevent or deter some of the outcomes that you might expect in these kind of events. However, the reason I'm showing these to you is for another reason. Most of the crowd simulation solutions oversimplify agent behaviors. Either they don't capture the complexity of human decision-making, emotions, or social interactions, or agents are very heterogeneous with little behavioral diversity, like personality, age, physical abilities. So we wanted to create cognitive agents embedded within crowd simulations to be able to show crowd dynamics, peer pressure, and stress responses that are rarely actually explored. So this is some of our attempts where we have created these crowd simulations and used reinforcement learning to develop intelligent agents capable of both simulating the threats and the occupants with diverse abilities and decision-making processes. We're taking this research to a next level where we're looking at how building design might affect evacuation outcomes. This is a collaboration between my group and Northeastern University. Here you see 4 different typologies of school buildings in the United States, and our goal is to simulate different threats in these school environments and also evaluate some of the interventions, design interventions, such as staggered doors, curved corridors, and others that the designers are considering. So this is also a collaboration with a different group of Arup, and mass motion is a very commonly used crowd simulation tool by engineers and designers. And we're working with Arup to integrate these cognitive agents into their crowd simulation software, mass motion. Lastly, I'd like to highlight a couple projects that are related to human-robot collaboration on construction sites. I like showing this image because one thing that it highlights, or these images, is how construction processes are still human-dependent. Every single image that you see there, you see a human worker, either assisting this semi-autonomous masonry robot or checking, doing the quality check. So this is a picture actually I took on my way to work. It says robots can't take your job if you already retired. It's a retirement or insurance company. But I think in the construction industry for the next 10 years or so at least, we're going to be in that sweet spot where humans and robots collaborate. There's so many interesting questions. For example, when you are collaborating in a mixed environment like that, who assumes the leadership within a crew? Is it the robot or is it the operator? How does collaboration between robots and workers transform construction workflows? We're not going to be able to follow the same workflows that we follow. How does trust in automation vary depending on the task in hand? But more importantly, this was mentioned by one of our speakers in the morning, that we are lacking skilled construction workers. And with increased level of automation, we need to upskill and reskill construction workers. So this is a training program that we have developed, powered by AI, that adapts based on the workers' learning abilities. It adapts to individuals' skill levels, adjusts the content based on their prior knowledge, and adapts to individual learning needs by repeating the content or slowing down delivery as necessary. But with this research, we realized that when it comes to remote operation of construction operation, like a demolition robot, sensory information is extremely important beyond just the visual information. Sound, haptic feedback, even smell provides essential context about the structure, construction site, surrounding environment, which are all crucial for safety on a construction site and efficiency. But machine-human collaboration in remote operation is very challenging. There are several issues like latency, communication delays from network disruptions, limited situational awareness due to reliance on cameras and sensors, difficulties in coordination and decision-making, and trust and safety concerns that may lead to over-supervision or reluctance to allow autonomous operations by the robot. So we're now working on these issues from object tracking applications to train machine learning models to specifically detect, for example, the end effectors, which our operators were very concerned about, and preventing unwanted collisions with the robot arm. This is a research where we collaborate with operators and machine makers. So it is a stakeholder-engaged research, which brings about the importance of industry-academia collaboration, because their challenges are really challenging for research projects and bring really interesting research questions to forward. Okay, so what is next? I have shown you a couple examples from my lab, but of course AI is transforming the AEC industry in many different ways. You're going to hear, I'm sure, today from many speakers how AI is being used for predictive maintenance, monitoring structural health, anticipate failures, optimizing energy efficiency, or simulating traffic flows and such. So, technology is reshaping our everyday experiences. But I challenge all of us to think about AI as not merely an add-on, but a fundamental catalyst for innovation in our built environments. We need to have continued research and development, and this is where I think Nemetschek Institute for the Built Environment plays a critical role, as well as your expertise as mathematicians, as designers, as engineers, and social scientists become really crucial. So we really have to put our collective skills in play and push the boundaries of what AI can achieve in shaping the future of our built environment. However, there are several challenges we must also address. Privacy is one of them. Simple air quality sensors, where we use to measure pollutants in indoor environments, we realize that can tell us quite a bit about individuals, who they're interacting with, what they're cooking, and all kinds of private information that we can extract, and many people don't think about this. So we really need to think about ethical deployment of AI in our work processes. Integration with existing systems is extremely important. We have many existing or historical buildings So how we're going to bring AI to those buildings, and also how we're going to bring AI to some privileged occupants, but to all occupants. Last but not least, it's really important to think about environmental impact. Computational power and water required for AI systems is an important consideration because AI is very power and water hungry. So we have to think about how we're offsetting energy savings achieved through AI-driven optimizations with the required power and energy by AI. Lastly, I love this quote. There is the risk of using AI merely for its own sake. It highlights the importance of using technology for the greater good of individuals and society. So we must always think if we're doing the right thing or we're all intrigued by technology, and admittedly, I'm one of those people. So lastly, we need interdisciplinary collaboration, and we need collaboration between industry and academia. And this AI transformation calls for bold thinking, not only automating our processes, but I think we have the opportunity to reimagining how AI can elevate both our profession and society, acting with purpose, and using AI as a force for a meaningful change. For me, the version of this vision is about future of buildings, where buildings are not going to be merely structures of the future, but rather active participants that perceive, sense, and reason about their surroundings, collaborating with users to support individual and societal goals. So can you envision your building as more than just a structure, perhaps like a machine, a teammate, a co-worker, or even a friend? So I'll leave you with a small clip from a podcast that highlighted my work that captures this idea beautifully.
What if your home was more than that? It was more than just an address. What if your home was like your friend?
What are you thinking?
You know, you and I enter our office building, your space would be personalized to you. Your space would know you in a very intimate way. Your space would know if you had a bad day or a good day, if you were tired and you needed more coffee, if you had appointments that day. Your space would be like your friend. It would be an extension of you.
That sounds interesting.
What if it could have a personality? What if your home was more than that?
Oops. So I'll leave you with that clip. Thank you so much for listening. And not sure if you have time for questions.
Yeah, thank you very much. So
yes,
inspiring.
And I'm happy to take questions.
We can take a couple questions before we go to coffee. I know we're a bit over time, but especially with that last very provocative and inspiring question. I'd never think of my office necessarily as my friend. Not necessarily, it's not something that I wouldn't like to go to, but I wouldn't really classify it as a friend, somebody I would like to, say, share the movie I saw the night before with. I think perhaps, I don't know if there's anybody else here that thinks that way, but for me that seems like a provocative extension, but not something realizable in the near future. But I'll open the floor. Does anybody have comments to make? Yes, please. What about the, yeah.
Hello. Thank you. So Miguel Martin from the Delft University. I'm visiting scholar at Carnegie Mellon. So thank you, Burçin, for this wonderful presentation. So I have a question related to one of the last points you mentioned, because I always have the feeling that AI, especially in human-centric applications, are quite energy-intensive, no? Because humans, needs a lot of attention, and AI, needs to operate constantly to understand their needs. So now, according to you, how can we potentially ensure that the energy we need to spend in AI for human-centric applications is balanced with what we can get in terms of building energy savings and, most importantly, I guess, improvements in terms of human well-being? Yes.
Mm-hmm. That's a very good question. I'm afraid I don't have a good answer yet, but I don't think it's just human-centered applications. AI in general, we're using in any other processes, even if human-centric approach is not there, has this potential danger. Unfortunately, the data is not made very available by AI companies in terms of how much water and energy use is required, and then there's pressing governments and other groups are pressing for these companies to disclose. But I do challenge all of my students when they're proposing something to consider those costs as well, not just how much we're saving in terms of energy efficiency in a building, but how much we're also using. Yeah. And I think this is an important consideration. I'm not saying that we should stop working. Of course, this is not the goal, but I am saying we have to be also cognizant about those issues. At the same time, we have to push the AI industry to address this, right? This is not an architecture, engineering, and construction problem necessarily, but as collectively, we can press on these issues as well, and they are going to likely going to make the changes, necessary changes.
Right. Last quick question. If not, we can go for coffee. We can certainly continue that question in a coffee break. No takers? Well, oh, yes? No? Okay. I guess everybody's thirsty. I'd like you to join me in thanking Burcu for a great talk.
Thank you.